Toyota built its reputation on reliability. But here is the truth most people will not tell you. Nothing about how Toyota builds million-mile engines is accidental. Every design choice, every material selection, every engineering decision traces back to principles most automakers abandoned decades ago. And once you understand what Toyota actually does differently, you will never look at reliability the same way again. Let's break it down. The first secret is Toyota's obsession with boring engineering. While other manufacturers chase horsepower numbers and flashy technology, Toyota engineers spend years perfecting things nobody talks about. Water pump bearings, oil passage geometry, gasket material composition. These are not exciting features that sell cars on a showroom floor. They are invisible decisions that determine whether an engine survives 100,000 miles or crosses 1 million. Toyota's internal philosophy is simple. If a component can fail, redesign it until it cannot. The 2GR V6 engine went through 7 years of development before reaching production, not because it needed more power, but because Toyota engineers kept finding ways to reduce internal stress points that might cause problems at 300,000 miles. Most manufacturers would have shipped it years earlier. Toyota waited until the math proved it would last. The second principle is over-engineering without apology. Toyota components are consistently rated 20 to 40% stronger than the forces they will ever face in normal driving. This is not marketing. It is measurable. Take a Toyota timing chain tensioner and compare it to competitors. The spring pressure is higher. The plunger bore is tighter. The oil passages feeding it are larger. None of this shows up on a spec sheet, but it shows up at 400,000 miles when the chain still runs quiet while other engines rattle themselves to death. Toyota calls this design margin. Engineers calculate the absolute maximum stress a part will ever see, then design it to handle significantly more. That buffer is why Toyota engines survive abuse that kills other brands. It is also why Toyota resists the industry trend toward downsizing. Smaller turbocharged engines work harder to make the same power. Working harder means more stress. More stress means shorter life. Toyota's larger naturally aspirated engines loaf along at partial throttle while competitors strain at full boost. Easy miles add up differently than hard ones. The third factor is something Toyota never advertises: thermal management obsession. Heat is the silent killer of engines. Every degree of excess temperature accelerates oil breakdown, gasket degradation, and metal fatigue. Toyota cooling systems are deliberately oversized for this exact reason. Radiators have more capacity than necessary. Thermostats open earlier than competitors. Water pump flow rates exceed minimum requirements. This means Toyota engines run cooler under identical conditions. That temperature difference compounds over years. An engine running 5 degrees cooler experiences measurably less thermal cycling stress on head gaskets, exhaust manifolds, and valve guides. Toyota's hybrid systems take this even further. When the electric motor assists during acceleration, the gasoline engine works less hard and generates less heat. Over hundreds of thousands of miles, those brief moments of reduced thermal load add up to significantly less cumulative heat damage. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. The fourth secret is Toyota's material selection process. Most people assume all engines use similar metals. They do not. Toyota specifies alloys and heat treatments that cost more, but last longer. Camshafts receive specific hardening processes that resist wear at the lobe tips. Crankshafts are forged rather than cast in applications where other manufacturers cut costs. Piston rings use materials selected for longevity, not just initial performance. These choices are invisible to buyers, but they show up dramatically in oil analysis data. High-mileage Toyota engines consistently show lower levels of wear metals than competitors at similar mileage. Less metal in the oil means less metal leaving critical surfaces. It is simple math that proves out over hundreds of thousands of miles. The fifth principle involves Toyota's approach to oil system design. Oil is the lifeblood of any engine, but Toyota treats it differently. Oil passages are designed with generous cross-sections that maintain flow even as deposits accumulate over time. Oil pumps are sized larger than strictly necessary, ensuring pressure stays stable across all conditions. Oil filter placement allows complete drainage during changes, preventing contaminated oil from remaining in the system. Toyota's variable valve timing systems are particularly dependent on clean oil. The oil control valves have tight tolerances and respond poorly to contamination. Toyota engineered larger oil galleries feeding these components specifically to maintain flow, even with slight varnish buildup. This is why Toyota engines tolerate occasional late oil changes better than many competitors. The margin built into the oil system provides a buffer that prevents immediate damage. It is not permission to skip maintenance, but it is a form of protection against real-world imperfection. The sixth factor is production consistency. A reliable design means nothing if manufacturing varies from one engine to the next. Toyota's production tolerance standards are famously tight. Bore measurements, bearing clearances, and surface finishes are held to specifications that exceed industry norms. This consistency matters because variation creates weak points. An engine assembled at the loose end of acceptable tolerances will always wear faster than one assembled at the tight end. Toyota's approach ensures every engine leaves the factory closer to ideal specifications. Quality control extends beyond measurement. Toyota production lines empower any worker to stop the entire line if they notice a potential problem. This philosophy, Jidoka, catches issues before they become installed in vehicles. It costs production time, but it eliminates the chance of a defective component causing failure years later. The seventh secret is Toyota's gasket engineering. Gaskets seem simple, but they are one of the most common failure points in high-mileage engines. Head gaskets, valve cover gaskets, oil pan gaskets, and intake gaskets all degrade over time. Heat cycles, pressure changes, and chemical exposure eventually cause them to leak. Toyota invests heavily in gasket material development. Multi-layer steel head gaskets replaced older composite designs specifically because they survive more thermal cycles. Valve cover gaskets use rubber compounds formulated to resist the specific chemicals found in engine oil at operating temperature. These are not generic parts selected from a catalog. They are engineered specifically for each application. The eighth principle is Toyota's conservative approach to new technology. When direct injection became popular, Toyota was slow to adopt it. When turbocharging swept the industry, Toyota resisted. When variable compression engines emerged, Toyota studied them without committing. This caution frustrates enthusiasts who want cutting-edge features, but it protects owners from becoming beta testers. When Toyota does introduce new systems, they are typically refined versions that solve problems early adopters experienced with competitors. The D4S system, which combines port and direct injection, exists because Toyota engineers recognize the carbon buildup problems that pure direct injection causes. Toyota solved those problems before they became their customers' problem. The ninth factor is parts availability and standardization. A million-mile engine requires maintenance and occasional repairs over decades. Toyota designs with this reality in mind. Common wear parts are shared across multiple models and years. Replacement components remain available long after production ends. Service procedures are documented clearly because Toyota expects these engines to need work at 300,000 miles and beyond. This standardization also means independent mechanics can source quality parts without resorting to questionable suppliers. A water pump for a 15-year-old Camry is still readily available from multiple manufacturers. That accessibility keeps maintenance costs reasonable and ensures proper parts are always an option. The 10th secret is what Toyota does not include. Reliability often comes from simplicity. Toyota resists adding components that create failure points. Fewer sensors mean fewer electrical faults. Simpler intake manifolds mean fewer vacuum leaks. Conventional automatic transmissions in applications where continuously variable transmissions might theoretically improve efficiency mean proven durability over experimental optimization. Every additional system is an additional thing that can break. Toyota's approach asks whether a feature genuinely improves the ownership experience enough to justify its maintenance burden. Features that fail that test do not make it into production, regardless of how impressive they might look on a spec sheet. The 11th principle involves how Toyota engines respond to neglect. No manufacturer recommends skipping maintenance, but reality includes owners who occasionally miss oil changes or delay timing belt services. Toyota engines are designed with this human imperfection in mind. Oil capacity is generous, providing a larger reserve if levels drop between checks. Timing chains with a maintenance-free design replace timing belts in most applications, eliminating a service that many owners historically skipped. Cooling system capacity exceeds minimum requirements, providing buffer time if a leak develops. These design choices do not excuse neglect. They help prevent neglect from causing immediate catastrophic failure. The difference matters in real-world longevity. The 12th factor is Toyota's institutional memory. Toyota has been building reliable engines for over 60 years. Lessons learned from failures in 1985 influence designs released in 2025. This accumulated knowledge does not exist at manufacturers who reinvent their engineering teams every few years. When a Toyota engine experiences an unexpected failure pattern, the information flows back through the organization. Future designs incorporate solutions. This feedback loop has refined Toyota's engineering principles across generations. The result is engines that do not just avoid previous failures, they avoid entire categories of potential failures that Toyota's experience has taught them to anticipate. The truth about Toyota's million-mile reliability is that it comes from 1,000 small decisions, each one favoring longevity over cost savings, proven solutions over experimental features, and margin over minimum specifications. None of these choices are exciting. None of them make headlines, but together they create engines that refuse to quit. If you are enjoying this video, consider watching this one where I am sharing the exact maintenance schedule that keeps these Toyota engines running past 500,000 miles.